So I've already discussed the heavy metals category in the previous short video lecture. Let's continue with the synthetic organic compounds. Synthetic organic compounds are typically broken into categories, one of which is halogenated hydrocarbons. And these are basically hydrogen and carbon bonded together, in which there may be an atom of chlorine or bromine, fluorine, or iodine. And because that they are man-made chemicals, they do have some toxicity representation associated with how their compound interacts in the environment and with human health. Then we have chlorinated hydrocarbons, and these are also called organic chlorides, and they are considered the most common form of halogenated hydrocarbons. So they actually fall under the category of halogenated hydrocarbons. Examples of these chlorinated hydrocarbons include plastics, and one of the compounds commonly found in plastics is called vinyl chloride. Also, pesticides, and an example of that is DDT. Solvents, which help clean surfaces, and an example of that is carbon tetrachloride, which consists of one carbon atom and 4 chlorides attached to it. In addition, there's insulation materials, and a common one that we've used in the past is PCBs, or polychlorinated biphenyls. This chart on the right of your screen shows the number of nesting Florida bald eagles and how the population of the bald eagles in Florida was decimated by the use of DDT. The population was above 100 and even was as high as in 1948 as 150 nesting eagles, and then after DDT was introduced, you can see an immediate drastic decline in the population numbers of nesting bald eagles in Florida. This is a picture of DDT being sprayed at a beach. It's labeled as being a powerful insecticide, harmless to humans, and they use it to get rid of sand fleas. And this was just one example of how DDT was used to be sprayed even around people. So DDT was heavily used back in the day. DDT is considered to be a persistent organic pollutant, or POP, P-O-P. Other examples of POPs include heptachlor, hexachlorobenzene, aldrin, dieldrin, chlordane, PCBs, toxaphene, dioxins, and furans. In fact, the list that's here on your screen is known as the Dirty Dozen because they are chemicals that persist long in the environment and do not break down easily. So they were chemicals that were proven to be beneficial in the past for pest control and disease control and crop production. But these chemicals have had unforeseen effects on human health and the environment, and as a result, many of these chemicals have been banned and are no longer permitted to be used. So we're in a bit of quandary because there's definitely a need for pest control. You can see the pictures on the right are examples of different pests that attack plants. And a pest is considered an organism that is noxious, destructive, or troublesome. So they could be pathogens, or wild animals, or insects, or mold. An agricultural pest is further defined as an organism that feeds on crops, ornamental plants, or animals, and they fall into the category of insects, fungi, viruses, worms, rats, mice, birds. So pests destroy about 37% of our U.S. agricultural production per year, and this problem costs about $122 billion a year. So pesticides are actually categorized based on the organisms that they kill. There are insecticides that kill insects, rodenticides that kill rats and mice, fungicides that kill fungi, herbicides that kill plants or weeds. And weeds are plants that compete with crops, forests, and grasses, and hence farmers don't want the weeds in their fields because they don't want them out competing the crops that they're trying to grow. So all of these pesticides can pose a hazard to others, including humans. So the first generation pesticides were used to control pests like insects, and they contained lead, arsenic, and mercury. These pesticides accumulated in soil, and they inhibited plant growth, and over time they lost their effectiveness. So we then created what's known as a second generation of pesticides that were developed through synthetic, organic, man-made chemistry, and this resulted in the Dirty Dozen pesticides that were identified on the previous slide, which we later banned from further use because of the ecological and human health impact. Again, the Dirty Dozen includes DDT, Aldrin, Dieldrin, Chloridane, Endrin, Mirex, Heptachlor, hexachlorobenzene, PCB, toxaphene, dioxins, and furans. So, we still have a need for pest control, and I'm going to be talking about pesticides in the next couple of slides. In fact, that need is identified, for example, back in the early 1990s, we had a potato fungus that killed 70% of the potatoes in Russia. There's also a vampire weed that has caused billions of dollars in losses in East Africa. There's a soybean rust that has cost over $2 billion in Brazil just in 1 year. And now the soybean rust has moved to the United States and is impacting our soybean crop and has cost the U.S. $27 billion in a year. So the U.S. is spending a lot of money in order to stop the impact of pests on crops. So about $32 billion per year is being used to spread about 5 billion pounds of pesticides. Some of these are herbicides that kill plants, some of these are pesticides that kill animals and insects. But are there other options for us, other solutions that we could use in order to address the pest control issue but not use chemicals? Here's a list of different pesticides and some characteristics associated with them. The insecticide class is listed here, and we break them into categories of organophosphates, carbamates, chlorinated hydrocarbons, and pyrethroids. And the toxicity to mammals and their persistence is listed here. So the permethrin, the bifenthrin, and these chemicals have a low toxicity to mammals and a low persistence. So it seems like these would have the least impact on the ecosystem and human health. This is a list of different weed killers and what their effects are on plants and specific chemical names. And one that is very commonly used is glyphosate, and we'll talk about this one more later. So one point to note is that these pesticides that kill insects don't selectively pick which insects they kill. We have found that bees and butterflies are highly sensitive to these pesticides. So let's look at some more data pertaining to pesticide use. This graphic on the left depicts annual pesticide consumption worldwide, and it's data that goes up through 2012. It appears that China has the highest amount of pesticide use globally. Then that's followed by the United States. But looking at China, their use is about 4 times as much as what we use here in the United States. The graph on the right depicts the amount of use by year and crop, and the crops are color-coded here, for an herbicide known as glyphosate, otherwise called Roundup as a familiar trademark name. This is a weed killer, basically. And this graph is depicting the increased usage in millions of pounds per year over time. And we've definitely increased from 1992 to the 2015 timeframe. And it's evident that that increase has occurred. The crops that have increased the most are our use of glyphosate on soybean crops as well as on corn crops. And there's been moderate increase on cotton. Glyphosate is the most applied pesticide herbicide here in the United States. That's followed by atrazine, which is considered to be the second most commonly used herbicide in the U.S. Up to 80 million pounds of atrazine are used in the U.S. each year. In addition to causing severe harm to endangered species, atrazine exposure can be linked to increased risk of thyroid cancer, reproductive harm, and birth defects in people. A recent study showed that children whose mothers were exposed to atrazine had an increased risk of birth defects. Again, atrazine is the second most commonly used pesticide after glyphosate. In a 2015 article from the Center for Biological Diversity, the article states that the EPA has for decades continued to register and allow the use of pesticides without considering their impacts to endangered species, despite the legal requirements for them to do so and the well-documented risks of thousands of imperiled species to pesticides. A series of lawsuits have occurred by the Center for Biological Diversity, and it has forced the EPA agency to consult on the impacts of many pesticides on endangered species, primarily in California. And it's also resulted in some temporary restrictions on pesticide use in sensitive habitat areas. Last year, the Center for Biological Diversity entered a nationwide settlement with the U.S. Fish and Wildlife Service requiring the agency to analyze the impacts on endangered species across the country from 5 dangerous pesticides. Those pesticides are carbaryl, chlorpyrifos, diazon, malathion, and methomyl. They have been found to be toxic to wildlife and may pose a health risk to humans as well. In addition, another settlement is occurring which follows a similar framework and will require the EPA to begin consultation process on each of these chemicals. The EPA will analyze the impacts of atrazine and glyphosate, the 2 most commonly used pesticides in the U.S. And they're going to investigate the impact of atrazine and glyphosate on 1,500 different endangered plants and animals in the U.S. And this was based on a legal settlement that was reached with the Center for Biological Diversity lawsuit against the EPA. The EPA will also analyze the impacts of propazine and simazine, 2 pesticides that are chemically similar to atrazine. And it's committed to completing this assessment by the year 2020. So basically, 2 different lawsuits have forced the U.S. Fish and Wildlife Service and the EPA to consider doing assessments of specific pesticides and herbicides in relation to their overall impact to endangered and threatened species populations. In the top left corner of the screen, I have a link that can be clicked on to take you to a website that's maintained by the U.S. Geological Survey that allows you to evaluate U.S. pesticide use in a map format as well as graph format. This is that website. Basically, you can look at data from 1992 all the way through 2015 and determine estimated annual agricultural pesticide use. Currently, this graphic is showing the overall use for 2,4-D, which is a pesticide used in crops. And you can tell that much of the pesticide application is occurring in the Mississippi River watershed. I would like to focus on a couple other pesticides, specifically the glyphosate, since that is the most commonly used herbicide. So we're going to click on glyphosate, and we are going to go back in time here to see what the distribution of application looked like back in 1992. So in 1992, the distribution of use of glyphosate looks like what's here on the map. Now remember from the previous slide in the presentation that glyphosate use has increased dramatically since 1992 through 2015. So let's look at how this map changes over time. So I'm going to click through these kind of quickly, and you'll see how the color shading changes over time, with the darker tones indicating a higher application rate of the glyphosate in those particular regions. So you can see the trend and the aerial distribution that there's been an increase in glyphosate use throughout the United States. And 2015 is our end year. So just going back to click, this is what it looks like in 1992 for glyphosate use, and this is what it looks like in 2015. a definite increase in glyphosate use, which correlates to the graph that we saw earlier in the PowerPoint presentation that I showed you.